This is calculus class. We're gonna discuss series. Previous two videos, we talk about sequence and limit of sequence. Now, our attention to the series. So this first part of video, we're gonna talk about definition of series this time. Before we talked about infinity series, let's talk about partial sum. First, what is a partial sum means? Before we talk about partial sum, they have the sequence. When you have sequence, we're gonna define partial sum as n, S1, S2, Sn. So how gonna define partial sum of S1, S1 is A1. So I gonna write all the sequence A1, A2, A3, A4. General term is AN plus 1. Never stop, that's the sequence. So S1, partial sum, S1 is S1, A1, S2, A1 plus A2. S3, third term of partial sum is A1 plus A2 plus A3. Okay, that's the definition of partial sum. That's gonna be first term is gonna be S1 defined A1. Second term is A1 plus A2. That's how to define S2. S3 gonna be A1 plus A2, A3. So you can do the S10 A1 plus A2 plus A3 plus all the way A10. So you guys remember sigma notation from calculus 1 class. I'm gonna write this sigma notation. Index gonna be I gonna be start 1 and 10. That's the S10 partial sum. 10th term gonna be you add the sequence from A1 to A10. So what is S10? General term of partial sum is A1 plus A2 plus all the way, what is the last term? AN. We're going to write down the partial sum is I equal 1 to N AI. That's the definition of partial sum, okay? Next slide, we're going to practice finding partial sum. So I give the sequence. So we're going to partial sum general term. Before we find the general Sn, let's find what is S1, what is S2, S3. Let's find the three term, then find the general term of partial sum. So A1 is 1.5, A2 is 1 over 2 square, A3 gonna be 1 over 2 cube. That's the sequence. S1 is 1 over 2. S2 gonna be 1 over 2 plus 1 over 2 square. S3 gonna be 1 over 2 square, 1 over 2 plus 1 over 2 square plus 1 over 2 cube. What is gonna be Sn? 1 over 2 plus 1 over 2 square plus 1 over 2 cube. What is An? You're gonna add from A1 to An. So what is An gonna be? 1 over 2n. So this one plus 1 over 2n. Let's do the sigma notation. Sigma 1 over 2k. This time I'm using the k index this time, guys. Then k should be start point 1 end point n. That's the notation of partial sum. We find the partial sum. Don't simplify, just write each partial sum. Okay, let's do the second one. So A1 is 1 square, A2 gonna be 2 square, A3 gonna be 3 square, AN gonna be n square. S1 is 1 square, S2 gonna be 1 square plus 2 square, S3 gonna be 1 square plus 2 square plus 3 square, Sn gonna be 1 square, 2 square plus 3 square all the way n square. How can I write sigma notation, sigma k square k start point 1 end point n. That's right, the partial sum. Okay, so we understand what the partial sum means. The partial sum is another sequence from the sequence. Sounds weird, but that's the part of sequence, guys. So we're gonna talking about limit of partial sum. Let's talk about infinity series. The previous slides, we defined the partial sum from the sequence. Infinity series meaning is here's given infinity sequence is right there, guys. Then we're gonna add all the sequence. Here is adding all the sequence. Notation is a summation n equal 1 to infinity an. That's what we call infinity series. The big question is here is if you what kind of question you have, what is the how can find how could we find the sum of an? How gonna find this sum of an? So we're gonna talking about definition of infinity series. Next slide. How gonna find infinity series, sum of infinity sequence? So we want to find the value of infinity series. So here is we're gonna do it. When you're giving infinity series right here, here is right there, that's infinity series. So we're gonna find the partial sum first. Partial sum is gonna be, here is Sn, that's right down, general term is right there, guys. But I'm gonna put this way, guys. I'm gonna move this, here is right there. S1 is gonna be A1, right? S2 gonna be A2. So Sn is a partial sum A1 to the An. If we can find the limit of Sn, the limit gonna be S, then we're gonna say this partial sum is convergent, then this infinity series is gonna be S. The value of infinity series is gonna be S. If this Sn is divergent, then infinity series is divergent. So that's we're gonna find the value of infinity series. So what you have to do, this one is, guys, we have to find the partial sum first. So we want to find the infinity series, value of infinity series. We have find here, we want to find this value, right? Then we're gonna find the same partial sum and take a limit of this partial sum, then the limit exists, infinity series exists, that value is going to be S. The other way you rewrite it is on limit and approach to infinity. What is the partial sum notation is right there, summation I equal 1 to n ai. So we want to find this partial sum and take a limit, then limit exists, then infinity series, value of infinity series is gonna be S. That's how to find the value of infinity series. So what you have to first step, find the partial sum, take a limit is gonna be convergent, then we're gonna find the value of infinity series. Let's find infinity series. Let's decide if infinite series convergent to divergent. So what you have to first, we have to No, the partial sum. But this example is giving the partial sum. Sn is A1 to A2, AN. So they give the partial sum. That's the good news. So we're going to find here, find S1 first. What is S1 here? Guys, S1, they give the S1. So which meaning is Sn is 2n, S3n plus 5. That's another form of a sequence, guys, right? So S1 is right here n equal 1, 2, 3 plus 5, that's the 2 over 8, right? S2 gonna be, you plug in the n equal 2, this is n equal 2, 2 times 2, 3 times 2 plus 5, that's gonna be 4 over 6 plus 5, 4 over 11. Everybody make sense? So what is S3 gonna be? S3 gonna be right here, n equals 3, 2 times 3, 3 times 3 plus 5. That's going to be 6 over 9 plus 5, 6 over 14. So look at this one. This one is another sequence. So we're going to find the limit of partial sum, limit, and approach the infinity Sn. Then what are you going to say? This one. This one is limit and approach the infinity, 2n over 3n plus 5. Then we're gonna use, we studied how to find the limit of a sequence so many different ways. This one is you can use L'Hopital rule, right? So this one is gonna be find the derivative of 2n is 2. Find the derivative of 3n plus 5 is 3. Limit gonna be 2 over 3. So limit of partial sum is gonna be 2 over 3. Now we can find infinity series an, right? So this one gonna be what? This one gonna be 2 over 3. Then this infinity series converges. Guys, make sense? So when they give the partial sum, now we're gonna find the sequence this time, guys, okay? This is a partial sum. Partial sum, when you give the partial sum right there, you're gonna know the S1. What is S1? That's gonna be A1. So this one is n equal 1. So S1, A1, 2, 3 plus 5, that's the 2 over 8. That's the A1. Guys, right? This one is 1 over 4. So we want to know A2. They say A2. Let's, all you know, all you have is Sm partial sum. S2 gonna be A1 plus A2. So this one S2, n equal 2. We calculate 2 times 2, 3 times 2 plus 5. 4 over 6 plus 5 is 11. So S1, A1 is 4 over 1. S2, A1 plus A2 is 4 over 11. So now S2 minus S1, S2 minus S1, A1 plus A2 minus A1. What do you have here is A2, right? So S2 minus S1 is A2. So S2 gonna be 4 over 11 minus 1 over 4. That's you're gonna find A2. So this one is this common denominator 44, 60 minus 11, 5 over 44. Guys, make sense? Let's find SAN. So AN is same thing, S3, A1 plus, A2 plus, A3. We find this one, 2 times 3, 3 times 3 plus 5. This one 6 plus 9 plus 5, 14. That's the 3 over 7, right? 3 over 7. Now, I want to find the S3. S3 minus S2 gonna be A3 because S3 is A1, A2, A3. S2 gonna be A1, A2. This one is gonna be 3 over 7 minus S2 gonna be 4 over 11. So common denominator 7 is 7, 33 minus 28, That's gonna be 5 over 77. Now we're gonna find AN. How can find AN? Same process, guys. AN gonna be, guys, look at this one. So we wanna find AN. So AN is all you know, the SN. SN is right there. That's gonna be A1 plus A2 plus all the way AN. What is Sn minus 1? A1 plus A2 all the way an minus 1. So before the an, that's an minus 1 term. You're going to subtract. Subtract. Then here is Sn minus Sn minus 1. Cancel out everything. Cancel, cancel, cancel. What is left? An. That's find the an term. So let's find an. Here is Sn. Sn is 2n over 3n plus 5 minus Sn minus 1. You plug in the n with n minus 1. 2n minus 1, 3n minus 1 plus 5. So let's do this one. 2n, 3n plus 5 minus 2n minus 2, 3n minus 3 plus 5, 2n over 3n plus 5 minus 2n minus 1, 2, I'm sorry, 2n minus 2, 3n plus 2. So we want to find, that's the an term, guys, is 3n plus, that's the an. So we want to find the limit of this one. You find an right there, but we want to find the limit of an. Limit of an. So this one is the limit. So this one is infinity minus infinity. So this one is, we're going to find this limit this way, guys, okay? Let's go to here. N approach to infinity, 2n minus 3n plus 5 minus 2n minus 2, 3n plus 2.